Hello everyone, I am Tong Zhang, the speaker of this paper speech. The title of this paper speech is Connect Best During Stream Spatial-Temporal Convolution Human Behavior Recognition Technology. The authors are Xinyan Xiong and Tong Zhang of Harbin University of Commerce. The directory has 4 parts. Part 1 is research objectives and domestic and international status quo. Part 2 is human skeleton feature extraction. Part 3 is spatial temporal convolution neural network. The part 4 is experiment and result analysis. This is part 1. With the faster development of science and technology, for the application demand of intelligent synchronity, detection, human-computer interaction, and virtual realization, human action recognition has graduated into one of the host areas of computer vision and has received extensive attention from researchers at home and abroad. There are 2 ways of human action recognition. One is based on deep learning, which uses the convolutional neural network to train and test videos of data sets. The other method is based on Boolean synchronous. Human Boolean synchronous can be connected and modulated through connect and open pose. The sum algorithm can be used to identify human behavior. The use of human body identification technology, just like a media, game, movie, and sports competition. Now this is part 2. According to the biological theories, we can know that the human body is a complex structure. In order to simplify the analysis and calculation, we can simplify human body into a simple model as shown in the figure. According to the main bones and joints of the human body, this MI is the transformer, the coordinate, and M1 is the joint center point. Let the coordinates of the first joint point be M1 and locate this joint point as the main joint point, and then bring to the formula to calculate the transformer the coordinates of the remaining joint points. For example, input a spacetime imaging as G. If the female number of a certain value is T, the characteristic matrix of each joint point in the T female is expressed as N. The behavior of the human body is dynamical. In order to extract dynamical human behavior characteristic, the characteristic matrix set of all joint points in the T female is expressed as this. E is split up into 2 parts. The one is connection set ES of all joint points in a single female, and the other is the connection set EF or joint points at the same position in the T female. Then the vectors of two adjacent joint points can be expressed as this. The angle state, which between two adjacent vectors can be calculated according to the below formula. This is part 3. When the spatial temporal during stream convolution network performs human body recognition, it will process the video data from two aspects. The one is the spatial dimension, which processes the human behavior information in a single frame. And the other is in time dimension, which processes the optional flow picture generated by the optional picture information of continuous video frames. The during flow natural network structure adopts VGG60 network. The VGG network has 13 convolution layers and 3 FC layers. After each polling, the number of convolved channels of the network will double, which has the advantage of retaining more features. However, as the number of layers increased, the occurrence rate decreased. Therefore, this paper processed an improved spatial temporal direct flow stream natural network to solve this problem. This picture is the structure diagram of the spatial temporal during stream network. We changed the VGG16 network from the original during stream network to the current REST-NET15 network. The following picture shows the structure of the REST-NET15 network. The REST-NET15 network increased the depth of the during stream network. However, there are also some new programs, such as gradient dispersion, network degradation, so we add residual networks to solve their programs. This picture is a schematic diagram of residual model. The following picture is an improved spatial temporal two-fold follow convolutional network model conceived in this paper. This is part 4. Experimental environment is Windows 10 operating system. The CPU is Intel i5-10200H. The video card is GTX 1650 Ti 4G. The running memory is 8G. We use the MATLAB R2020B to building a deep learning framework. Use the OpenPose to decompose the video in HMDB 15.1 and UCF 101 datast into two parts. Space and time. The space is a single frame RGB image, and the time is an optional photo picture. The frame number of the video is set to 20 frames. If the frame number is set too large, the workload of the network training will increase. Use the Kinect Creamers ON group program to scan the bonus and joints. of the decomposed single-frame RGB image. Build a deep learning framework on MATLAB 20B. Replace the VGG16 network model in the original during stream convolution, and input the single-frame RGB image and the optional follow image into the replaced RESTnet 15 network model for the convolution process. The fusion model is the fusion model in the original network model. The train times are set to 14. The train set used 17% of the data set, and 30% is experimental set. The recognition has a central of 69.4% on HMDB 15.1, and the recognition accuracy of UCF 101 is 19.3%, which is significantly improved. Our results are significantly better than those of other research methods. This picture is a comparison with other research methods. By replacing the VGG16 model, which the result RESTnet 15 model, and adding residual connection to the network, the depth of interior network is increased and the network performance is improved. The addition of residual connects reduce gradient dispersion and the network degradation programs through the network, thereby improving identification accuracy. Thank you for your participation.